to get a reliable, usable, consistent dev environment. And we're going to talk a bit about that problem. We're going to talk about some of our favorite tools for solving that problem today. I'm going to start off with a bit of a story. Story time, everyone. Josh spins his chair around to Maxine. Mrs. Chambers, I've got to show Randy something, but I just emailed you what we've got in terms of documentation for new developers. There are wiki pages where I've assembled all of the release notes we've written and the documentation from development teams. There's also links to stuff we know we need to write. Hopefully that'll get you started. Maxine gives him a thumbs up. As they leave, she logs onto her new laptop and is able to get in and open her email, miraculously working the first time. But before looking at what Josh sent, she pokes around to see what else is on her new laptop. Immediately, she's mystified. She finds links to HR systems, network shares, company resources, links to expense reporting systems, payroll, time card systems. She finds Microsoft Word and Excel and the rest of the Office suite, and she frowns. This is fine for someone in finance, she thinks, but not a developer. There are no developer tools or source code editors or source control managers installed. Opening up a terminal window, she confirms that there aren't any compilers, Docker, Git, nothing. Not even Visio or OmniGraffle. Holy cow, what do they actually expect developers to do? Read emails and write memos? When you hire a plumber or a carpenter, you expect them to bring their own tools, but in a software organization with more than one developer, the entire team uses common tools to be productive. Apparently here on the Phoenix project, the toolbox is empty. She opens her emails to see what Josh sent. It takes her to an internal wiki page. She tries to scroll up and down, but the document is so short, there isn't even a scroll bar. She stares at the screen for several long minutes. Screw you, Chris, she thinks. I'm Alex. I'm a consultant. I call myself a DevOps coach, mentor. I help people to understand what DevOps is and to put it into practice. I specifically focus on the database area. I learned my skills working for Redgate, which is a great company. I used to work there, but I quit because I didn't want to sell software. I wanted to help real people solve their problems. And so that's why I started a consulting company. I'm the co-organizer of Data Relay, which is a conference in the UK, which I'm going to tell you a little bit about later. I'm the founder of Speaking Mentors. So if you want to get into speaking, either at a user group like this or a conference, and you would like some help from somebody that isn't in your immediate area of, that isn't necessarily one of any of the people in your group, then check out speakingmentors.com. There's a whole bunch of us up there who have said we're willing to give our time for free to new speakers. And I'm a Microsoft Data Platform MVP. Sander, do you want to introduce yourself as well?
Yes, I will. I'm Sander. I'm a SQL Server DBA. The majority of my work consists of automating about every repetitive task there is. I loathe doing anything repetitively. I will rather just spend a week automating something than do it twice. So that's why I do a lot of stuff with PowerShell. And that's why I also created the dbaclone that we'll be talking about today. I've worked in a variety of industries from agriculture to finance and healthcare. So I've seen it all. I'm a major contributor to the DBA Tools project. Like I said, I'm the dbaclone maintainer because it's an open source project. And I'm also an MVP in the cloud and data center area. So that means I do a lot of stuff with PowerShell. So yeah, that's me.
Cool. So let's talk a bit about the Unicorn project. Maxine Chambers, this is a book that I was just reading from. I made the mistake, by the way, of turning the lights off to try and get the nice camera here, and now I've realized I actually can't read it when I'm doing this because all the light is coming from in front of me. So the main problem Maxine had when she was getting started was it was impossible for her to set up a dev environment. This is a common problem in the tech industry, that when we onboard people, it's almost impossible for them to get up and running with the system. And with databases, it's even more problematic because typically it's hard to provision local databases for each developer. But this leads to a really big problem, and that's the use of shared development databases for either dev or test purposes. A lot of us use shared development databases. Some of us might even advocate for them, but they're wrong and they're evil and they cause enormous numbers of problems, both directly and indirectly. And we need to tear them away. And if you do advocate for them, I'm sorry, you're wrong. Just do not be using shared dev or test databases as much as possible. Obviously, the closer we get to production, the more we want to test it in as realistic test environment as possible. But so obviously at some point we're probably going to move to some sort of staging environment, but the dirty truth of the matter is that no environment is the dirty truth of the matter is that no environment is like production apart from production. So as much as we try and make it like production, it's never really going to be like production. I've just realized I've got my I specifically designed these slides so that they could have the text over the top of them. I'm just going to change my settings slightly. My apologies. Where is it? It's in slideshow. And I want to have subtitles at the bottom over the top. Let's try again. There we are. I think that's going to work a bit better. Let me just move my screens about again. There we are. Cool. So why are shared databases so horrible and evil? Well, the first reason is that you have no isolation of work. If we're all working on a shared dev environment, then my stuff is there, your stuff is there, somebody else's half-finished stuff there, somebody else's abandoned test stuff is still hanging around there. So when I'm testing stuff, I don't really know if it's working because my thing works or because my thing works when your thing also exists. And the other problem is true as well. If somebody else breaks it, they've broken it for me. I once worked in an environment where there are about 100 developers working on the same shared dev database, and some clever person managed to accidentally delete all the users on the SQL Server instance, or the logins, sorry, at which point the entire dev team was locked out. And the DBAs who needed to come and fix it would not come and fix it because there was a production issue on at the same time. So the entire dev floor was locked out for about a week. Which sounds crazy, but this is the stuff that a lot of us have to deal with. But the problem isn't just in the development area, it's also when we come to deploying to production. If we use shared databases with multiple people doing multiple different pieces of work at the same time on the same environment, when it comes to deployment, if we're not using source control very well, what we end up doing is comparing one environment to the next environment, doing a diff, looking through all the changes. That's my change, that's your change, this wants to go in, this wants to go out. We end up in complicated situations where we've both used the same stored procedure. So we want my bit, but not your bit. And it's a horrible, horrible change. And it means that as much as we want to do DevOps, as much as we want to do automated deployments, we can't, because every single deployment is a custom merge of what's on the dev environment to what's on the production environment. It leads to inconsistencies. It leads to failed deployments because we're never really testing the deployment. Look, when I deploy to production, what I want to do is deploy a single immutable thing as a single object to each environment. And I want to test that thing in isolation in each environment. And I want to test that that precise deployment works. And whenever I'm trying to do diffs between different environments, that just fundamentally isn't there. And it causes all sorts of slow, manual, painful deployment processes. And a lot of the time in database world, we're just programmed to think that's how it's supposed to work. So we tend to think that's how so it's hard for us to imagine a better way of working, but there is a much better way of working. We also end up with having all of this project management that needs to be added on top of it, because we need to coordinate what this person is doing and what that person is doing. We need to coordinate all these releases with all the other dependencies. So that is like a huge project management overhead that just poisons our productivity. And also this becomes an overhead for the DBAs as well, because once we start using a shared development database, especially if it's shared by lots of developers and even worse, lots of development teams, it ends up being the responsibility of the operations team, not the development team. And that's a time sink for the DBAs because they've got better stuff to do. They don't want to be worrying about looking after the developers' databases. Developers should be able to handle that. You know what? If developers had to look after their own shared databases, they might learn a thing or two about database administration, and they might stop making all those mistakes that the DBAs get frustrated with. And what actually, so it's not great for DBAs, and it's also bad for developers, because if a developer ever needs a new dev environment or they need something changed, they end up needing to log a ticket with the DBAs, and it's a big long wait. It's just a pain. And my final thought on why shared dev databases are evil. Imagine you're a web developer and you're in a team of web developers working on some website or web application or something. How you would work, if any of you have got any experience doing any sort of application or web work, you check out the code, you build it on your own machine, you compile it, you test it, you check it into source control, and off it goes. What you don't do is put all the files on a file share and let the entire dev team hack away at it at once. You'll never be able to get that to compile because somebody's going to be halfway through doing something. But that's what we're expected to work with in database land. It's crazy. We need to stop doing it. So we need to move to dedicated environments. And there are a few often commonly touted reasons why people think that's a bad idea. There are these problems that we have to overcome. But these problems are not insurmountable. They're solvable problems now. And it's important that we do solve them, because the people that aren't working this way and the organizations that don't work this way are working with a fundamental disadvantage compared to their competitors who are. So what are these main problems that we have? And you're probably familiar with them. You can probably tout them back to me. The first is managing changes. When everybody's making changes all at the same time, all in different places, trying to keep track of who changed this, who changed what, is difficult. But this is a solved problem. Developers solved this with source control years ago. Developers just need to start using it properly as it's intended to be used, rather than just as an auditing tool. We also have the data. It's big. Databases tend to be bigger than web applications. If you've got a terabyte of data in your production database, and copying all that data around is going to be a big problem. And that leads on to the next question, which is data privacy and data breaches. We do not want to be putting all of the sensitive production data onto developers' machines, because that's what data breaches are made of. Now, my argument here is that actually moving to a dedicated model doesn't make a difference here, because you shouldn't have that data in your shared dev environment anyway. If all of that sensitive data is in your dev environment, you're already doing it wrong, whether that's shared or dedicated. So in either case, you should be scrubbing that out. Of course, if you're not scrubbing that out, then you're going to be especially scared of going to the dedicated model, but you should be doing that anyway. So they're the big problems that we need to solve. And in today's class, in today's session, we're going to talk about some of the solutions to some of those problems. We're not going to get in a big way into the data privacy thing, in the data masking stuff. I'll kind of point at where this problem should live and where you would solve it and how you would fit it within this process. But that's a whole topic in its own right. I think I saw Steve Jones on here earlier. He's one of your group, and I'm sure he can tell you all about data masking because he works for a company that has some quite good tools for that. But I'll let him sell them to you on some other occasion. So right, the first thing we're going to look at is GitHub. We're going to start with, from the very, very beginnings, from the very, very basic steps, how do I keep track of the changes? That's the first problem. How do I keep track of who has changed what and when in a world where we're all working on our own environments? And the way that we're going to do that is we're going to use source control. Basically, the only source control system that it's sane to use in 2021 is Git as a technology. Centralized source control systems are like so last century. Distributed, basically Git has become the de facto standard. It makes life so much easier when you're recruiting new talent, or when you're looking for a new job, because it's basic. There's like the whole network effect going on. You don't have to learn a new source control tool every time you go to a new job, and Git has basically won that war. For those people who are still using distributed source control systems, I've got a bit of a cheat slide here for you to help you figure out the key difference between centralized source control, like Subversion, CVS, old school TFS, and distributed source control systems. So in the old world with TFS or Subversion or something, you would have your repository on a server and you would check out the code that you want, just as files. You'll make your changes, you'll check them back in. And that's all well and good. But now, just for a second, like, take a leap of faith with me. Imagine if there was some global worldwide event that meant that we all started working from home. I mean, I know it's hard to wrap your head around what that might be, but just imagine for a second that we're all working over some flaky VPN back to our main office. Wouldn't it be really nice and convenient if most of the stuff that you need is kind of local? One of the things that Git does that's really nice is you don't just check out the files, you clone the entire repository, history and all. So then you can make multiple commits locally and your latency is practically zero. You don't need to worry about flaky VPNs. You don't need to worry about any of that stuff. You could have a network issue between you and wherever you're working for, and you'll be able to continue working fine because you're not reliant on a connection to that central server. So that's one great thing. That's one great reason why Git is great. But one of the other reasons why it's great is basically that it's far better at handling, keeping track of the changes that one person has made and the changes that somebody else has made. And this gets into a complicated discussion about branching. I should probably say that one of the ideas I'm taking from this, one of my ideas behind this presentation is I'm not going to get too deep into the tech. I'm going to get deeper into the problems and I'm going to show you the solutions. And if you want to get deeper into the technical details, then that's what kind of documentation and deeper resources are there for. What I'm trying to do here is help you to understand there's a different way of working. So I'm not going to get too deep into the ins and outs of how Git works relative to centralized source control systems, but it handles branching an awful lot better. It handles working disconnected an awful lot better. And there are various other different advantages. And there's a whole network effect going on as well. So Git is basically the source control tool we use. GitHub is a website owned by Microsoft now that hosts them for you. So you don't need to worry about the administration of looking after all of your GitHub repos. One of the pieces of advice I'm going to give you about how you use your Git repository. So Git makes branching insanely easy compared to old school branching source control systems. A lot of people are kind of nervous about creating branches because they've been burned by it in TFS or SVN. Git kind of goes too far in the other direction. It's insanely easy to create branches and you can end up with a spaghetti soup of branches. So as you start using it, I do encourage you to practice something close to trunk-based development. It's actually in these two books, Accelerate and the DevOps Handbook, which are two fantastic books. I highly recommend them. This is more of a manual. This is more of an analysis of the business benefits of DevOps. These are great. Read this one first and then read this one. One of the things that both of them really, but Accelerate really goes into detail on is that organizations that practice trunk-based development tend to perform significantly better with respect to IT performance and with respect to business outcomes as well, measured by profitability, market share, and there's another one. I forget what the other one is. But basically, using these IT practices does have a measurable impact on business outcomes. The basic point of trunk-based development is never let anybody get too far away from the main line in source control. It used to be called master, now we call it main. Never get too far away from that. Any piece of work should be small enough that ideally you can finish it and commit it and push it to production in a day, which is a significant change in the way that we work for a lot of us, but it does make a significant difference. So that gives you an overview of Git and GitHub, kind of a super high level overview of basically this technology that can be used to essentially share files. But we're talking about databases. They're typically MDF and LDF files and they're all binary code. Like it wouldn't make very much sense. Like you don't put those in source control because they're too big and they're not human readable. What we need is a way of converting those MDF and LDF files into something that is human readable and small that we can stick in source control and we can diff properly. And that's where tools like SSDT comes in. And there are many others as well. There's Redgate that have got great tools for this. I'm sure Steve can tell you all about those. There's Flyway, there's dbaclone. There's all sorts of different tools that we can use to look after our source code. How SSDT works, it's a model-based tool, and they're kind of two different types of tools that translate your MDF and LDF files into human readable source code. The model-based tools kind of define how the objects are supposed to look. The migration tools define a set of upgrade scripts that you want to run. Both work perfectly fine. There are positives and negatives to each. I've got a separate session which goes into the details of them, which I can call out after the session, but I'm not going to get too much into that here. The point is that SSDT is a model-based or a state-based source control solution. It converts your stored procedures, your views, your tables into create scripts that define how you want each of these objects to look. At any point in time, you can the then source of truth of the latest version of your code is those scripts. And you can compare them and you can deploy them using the DACFX framework and a tool called SQL package and various other bits and pieces to deploy that code to your production environment. So what we're going to do now is Sander is going to do the first of 3 demos, and we're going to build it up bit by bit. And in this first demo, what he's going to do is just deploy the source code for a database using SQL Server data tools. And he's going to show you a couple of cool ways about how to create that project nice and quickly and easily. So Sander, over to you.
Yes, thank you. So I'm going to share my screen. Oh, you're still sharing, so if you can stop sharing so I can take over the screen.
I need to stop sharing, don't I? Yeah.
Yep.
Where's my Zoom gone? There's my Zoom. Oh, there it is. Stop share.
So our screen, that one. So you can see my Visual Studio Code screen, right?
Yep.
Okay, cool. So when I wanted to get our databases in source control, we had about 35 to 40 databases that we had to do. And if you go into Visual Studio and create your Visual Studio project, your SSDT project, you have to do a lot of clicks and you have to create multiple projects in your solution because I always want to separate the data model from the tests and all those kind of things. And doing that manually was a lot of work. So what I did was I created a template that you can get from my GitHub page. And that is a full SSDT solution that you can just use. It uses the PS module development PowerShell module, where you can just say, okay, this is my template, and then I want to rename it. And with some tweaking, I got that to work. So this entire script, it looks very, very long, but most of the stuff is just downloading the template and unpacking it and making sure everything is installed. And the most important command in here is just invoke psmd template. And it has a template name, a project destination, and a project name. And if I run that, I get something like this. Just for the sake of time, I'm not going to run everything because it takes a little time. But this is literally done in seconds. And if I have to do this like 35 times, I get crazy in a couple hours because, yeah, I don't like to do repetitive tasks. And if I open that solution, it gives me two projects. Oops. Go back. So I have the data model and I have the tests.
Hey, Sander.
I like to. Sorry.
Hey, we're seeing the one screen. Are you showing different screens?
No.
Or okay, all right.
I'm
sorry.
I'm showing Visual Studio.
It's just in the
PowerShell
console.
Sure. Wait. And I didn't share it correctly.
Yeah, Sandra, I think you're sharing the application rather than your screen.
Yeah. I selected screen, But let me check. Where is that little bugger? How do I unshare? Oh, oh,
The sharing tools typically get hidden up at the top.
yeah. But oh, it's all the way in the other end. So new share. I did share my screen. Let's do it again. So this is better. This is the correct screen.
There we go.
Yeah.
Where
Now you
is-
can see. So this is the entire thing that happens. And then you get this solution. It just generates it in a couple seconds. And then if we go to Visual Studio, you get this little project. And here's the data model, and here's my tests project, because I want to do unit tests with my all my databases. And I'm going to show you later on in another demo how you can actually generate those. So you can use that project, and then you go into right-click, import, and then you can just import your database or use schema compare, something like that, to get your project up to date with your production database. So the next step would be, like I said, I want to create unit tests for my databases, and I want to know if all my tables are there, or my store procedures there. Do my views have the correct columns? The same thing for the tables and the parameters for all my store procedures. So if you have a lot of objects, then you will end up like in the thousands of tests. So in the meantime, I created a PowerShell module called the PST/SQL test generator. And what that does is it takes the current state of your database and then iterates through all the objects and then creates unit tests for you. And those look a little bit like this. So one of the things it does, which is really important, check the collation of my database. Another one, test if my table is there. Maybe one of the developers accidentally deleted a table and then pushes it out to be tested. And the table should probably be there, or the tests shouldn't be there. Another one, test for the tables. And these are all generated for you. And this is all in that little command right here. Don't run this every single time, because if you do that, then it will always be successful, because it will generate the latest state of your database, and then it doesn't work. So only do this for specific objects, or do this at when you initiate the project and want to get all the tests. But don't run this every single time for the entire database, like I said. Then it will always be successful. So I think we're also going to do the build, right, Alex? Where's that in the next slide? Alex?
Sorry, I was on mute. Yeah, sure. Do you want to deploy it
yeah.
and show kind of the F5 deployment of a SSDT package?
So the next time the next thing I'm going to show you is we can actually use DBA tools to publish our DAC pack. So in this little script, I have the MS build path for where my ms-build.exe is located. I have my project file, and then I'm going to run ms-build, and then I'm going to do a deployment with my database using the DBA tools command publish DBA DAC package. If I run that, in here, there we go. So it's going to do the build, and then it's going to do the deployment afterwards. So in a matter of minutes, you could initiate your project, create all the unit tests, which we'll test later on in a later demo, and do publish that to one of your SQL servers. If I go to my server, then here is my latest database. Doesn't have any data in it. It doesn't have anything, but it's just the objects. So we're still not there. We're just developing locally, but we don't have any data. But we can do the initialization of the project and deploy everything, which gets you started. And that is a couple ways how you can do this very fast. So back to you, Alex. I'm going to unshare. I can find my stop sharing. Alex can show the next slide.
Share screen. Cool. And it's story time again. This time, the very serious business book about DevOps we're going to read is Oh, the Places You'll Go by Dr. Seuss. You can get so confused that you start into race down long wiggled roads at a breaknecking pace and grind on for miles across weirdish wild space, headed, I fear, toward a most useless place, the waiting place. For people just waiting. Waiting for a train to go, or a bus to come, or a plane to go, or the mail to come, or the rain to go, or the phone to ring, or the snow to snow, or waiting around for a yes or no, waiting for their hair to grow. Everyone is just waiting. Waiting for a fish to bite, or waiting for the wind to fly a kite, or waiting around for Friday night, or waiting perhaps for their Uncle Jake, or a better break, or a pot of boil, or a better break, or a string of pearls, or a pair of pants, or a wig of curls, or another chance. Everyone is just waiting. No, that's not for you. Somehow you'll escape all that waiting and staying. You'll find bright places where boom bands are playing. This is a book that's close to my heart because I often read it to my son. Actually, you can see that there's sellotape here that from where it's been battle worn, reading this book to my son. I think it's a lovely book. And I was, am I sharing my screen? Yep. And I was reading it when I was reading the Unicorn Project for the first time in that chair, which is just, I don't know if you can see in here, but it's just over there. That's my reading chair in this corner of my office, currently with a cat on it. When I was reading the Unicorn Project, this book was right by my side. And there's a point in the Unicorn Project where Gene Kim, the author, compares working in IT to the waiting place from Oh, the Places You'll Go. In any IT organization, almost all of them, it feels so often like we're always waiting. I can't do anything because I'm waiting for somebody else to give me this or somebody else to do that, especially when it comes to environments. We're always waiting for somebody else to give us the environment that we need so we can do the thing that we can do. It's never as simple as just doing that 2-hour piece of development work. There's a whole string of things that need to be done by other people to allow us to make it happen. So Eliyahu Goldratt, who wrote this book, The Goal, which is excellent. It was kind of the precursor to the Phoenix Project. And the Unicorn Project, and it's actually a book about building cars rather than about building software, but the Phoenix Project is based on it. In that book, Eliyahu Goldratt talks about the fact that in any process of work, there's always one constraint, or there's always a set of constraints or one constraint, and any improvement that we make that's not at that constraint is a waste of time. And why is that? Well, let's imagine the constraint is building ourselves a dev environment. There's no point putting more stuff on the backlog and adding to that backlog and getting really, really effective at that part of the process if we're still bottlenecked lower down. When we end up improving things before the bottleneck, all we do is just create a huge list of work building up in front of that bottleneck, and it doesn't actually make us any more productive. It doesn't make the business any better off. And if we make any improvements downstream of the bottleneck, then those areas just end up starved of work, and it's not helping us actually release our product or make improvements any quicker or any faster. All we're doing is creating a huge amount of additional overhead and delays and politics and bureaucracy, which is actually just adding to our problems rather than helping us. So the most important thing in any IT process improvement is to figure out where our bottleneck is and to then focus on solving that problem and not wasting our time solving any other problem than the problem that's at hand. And Gene Kim takes us a bit further. So in Beyond the Phoenix Project, which is an audio book that follows up on some of the concepts from the Phoenix Project, a direct quote is that what I find so amazing is that as an organization goes from code deployment lead times, that's how long does it take to go from the backlog to production, from code deployment lead times that are measured in months, maybe even quarters, down to minutes, the constraint moves in some pretty predictable ways. And he goes on to give this order: environment creation being right at the top. The number one constraint that most organizations, and not all organizations, and every organization will vary a bit, and it might not be for your organization, but the vast majority of them find that environment creation is the biggest and first bottleneck that they face when they're trying to improve their processes. After that comes code deployment, testing, architecture, and eventually it's how quickly you can come up with new ideas. And that's where you want it to be, right? The most effective organizations will be able to get their ideas into production and test them out and try them out basically as quickly as they can think of those ideas, and be constantly iterating and refining them and coming up with better products as a result. That's where you want the bottleneck to be, and then we can start really, really improving our ability to get stuff done. But those first four are all about practical IT things. It's nothing to do with how great our next idea is. And these are the things that are holding our businesses back. And environment creation being the first bottleneck is kind of the reason why when you think of a DevOps tool, it's almost always something like the first ones you think of are likely to be environment infrastructure as codey type things: Puppet, Chef, Terraform, ARM templates, PowerShell DSC, all of this stuff that helps us to, at the click of a button, build our environment infrastructure. And it's a huge enabler. And one of the things that it's great for, and probably the main thing it's great for, is spinning up dev environments as and when we need them. We can spin them up, we can tear them down, we can be properly, we can treat them like cattle rather than pets, which is a common DevOps mantra. We can, if we make mistakes on them, we can blast them away, we can build them again from scratch. And that's what we want to achieve. It helps us, yeah, that's what we want to do. However, when we're dealing with databases, we don't really have that. If we just stop based on the level of technology that Sander has already demonstrated, all we're doing is deploying the databases. We're not doing anything about the underlying infrastructure. All of us have got our own SQL Server instances that we're working on. And how many of us install SQL Server with the same settings every time? We want those dev environments to be consistent, standardized, all the same. I've worked in environments that have run into issues because one developer or another developer used a different collation on their local environment. That ended up going into source control, and they deployed the wrong collation of something to production. And that's a just frustrating problem to have to solve. So we want to make sure that all of our dev environments are created consistently. Correct version of SQL Server, correct settings, all of the dependencies are included by default. And this is going to help us get around it works on my machine problems. And one of the best tools for solving that problem is Docker. Now, this slide I have shamelessly stolen from my good friend Andrew Prusky, DBA from the cold, the container guy he's known as for SQL Server. He's a good friend of mine, and this comes from a session that we did as a joint session. I've spoken to him about it. He's very happy with me sharing his work. So what is a Docker container? Well, let's start by thinking about a Docker container as a VM. It's the same sort of thing. You're basically running a little computer on your computer, except where a VM includes an entire full-blown copy of the operating system, the container reuses the host's operating system. And that might sound like a subtle difference, but it's massive. It means that each time I install a new container, I don't need to reinstall the entire full-fat operating system all over again on my machine. That means I can pack significantly more containers onto a machine. It means that I can spin them up far, far more quickly because I don't need to worry about booting them or anything like that. it means that all I need to worry about is the applications and binaries and so on for that container. They're far more lightweight. I get a lot more bang for my buck with them. They're much faster, much more lightweight, much easier to work with. And you can now put SQL Server in a container on a Windows machine, which for a lot of us is what we want to achieve. And that's really handy. I'm not going to get into the details about how Docker works. We're kind of going to show you the consequences of it and how cool it is. Basically, you just need to make sure that you've got the latest version of Windows, or the server version, or the pro version of the desktop version of Windows. You need to enable a couple of features, and then you can do exactly what Sander is about to show you. Take it away, Sander.
Yes, so I'm gonna share my screen again. So actually, what now it has, the Docker installation changed in the benefit of the user, because you don't actually have to enable all of stuff. It works with WSL at the moment, which is a Linux subsystem in Windows 10.
Oh, you're right. I forgot about that. Yeah,
so,
look in my slides.
So you no longer need Hyper-V. You can still do that stuff, but if you use WSL, it's actually faster and more secure. So I have a container running, SQL Server 2017, SQL 1, and this one has just one database, which is the Stack Overflow 2013 database. And the thing I want to do is to show you that actually what we do with the publishing of the DAC pack is exactly the same, whether or not I'm doing it on a local instance or in a Docker container, because it's still the same command. I'm still publishing the same DAC pack to a server. The only thing that I'm doing different is that I'm, because it's a Linux subsystem and it doesn't have the Windows authentication, I need a SQL credential. So if I run that, build for Docker, it will do the same build and publish it to my Docker container. By the way, if you install SQL Server on a Windows system, it takes about 4.5 to 5 gigabytes of data. The Docker container image is about 1,500 megabytes. So it's significantly smaller as well. So here is my build. Same stuff that we did before. So there's no difference in how we work, and because I also love the infrastructure as code. So if we go to a new version of SQL Server in production, I can just tell the developers, hey, stop your container. Now update your script with the latest container image that we want to use. And then they run on the same version as everybody should, so as production. Because we actually had the problem that people were working in SQL Server 2012 to 2017, all the different versions, because they never got updated, and RTM releases and all those kind of things. So this is really a benefit of using Docker, which makes things easier to deploy and to install. So that was that for publishing into containers. It's that easy. Search for that little share. Where is the share? There it is. Keeps hiding from me. So back to you, Alex.
Cool. Let me start my share. One of the nice things about pre-recording is we can automate this toggling between one and the other. Trying to figure out how to do that on a Zoom call is a bit harder. Cool. So what we've done there is we can spin up Docker containers, we can deploy our code to them, and that's great. Before we carry on, there we are, back to story time. We're going to revisit Maxime in the Phoenix project. And what she's trying to do at this point is to try and actually get the build running on her machine. Maxime opens up a terminal window on her laptop and starts following the instructions Kurt gave her. Her excitement grows when she realizes this might actually work. She's exuberant when she's able to log in and type make on a command line, which starts streaming screenfuls of happy output onto her screen. She's delighted as she sees files getting compiled, binaries getting linked, programs being copied, build tools being installed and run. The output keeps going and going and going. Amazingly, things are still running for 10 more minutes, 15 minutes, 30 minutes. She's relieved that it keeps going without an error, but she starts to become alarmed at the size of the Phoenix build. It's huge. Then I've cut a bit. Like most developers, she's very superstitious that if she stops watching the build, it will fail. Finally, nearly 3 hours after she started the build, she sees a scrolling output from the bottom of her window stop. Her heart falls when she reads builder error, missing file, credentials.yaml. Damn! She's guessing she needs a login credential that she doesn't have. She texts Kurt and he quickly replies, yes. For that, you need to open a ticket to get your login tied to your Active Directory account. Only Susan can issue those. Contact info coming. The waiting place, all over again. Now, typically for databases, we're not necessarily talking about compiling that sort of environment, but that story is reminiscent of the problem of data. Now, we can all talk about what sort of data we want in dev databases, and we can argue all day about it. I'm not going to get too much into the detail, but fundamentally, we do want some sort of good test data. We want it to be realistic, because if we don't trust that our data is realistic, then when we get weird results from that query, well, is that because my query is bad, or is that because I've got rubbish data in my dev database? I want a reasonable amount of data because I want to be able to spot performance issues in the dev environment. I don't want to start deploying my cursors to production and then have the DBA coming and swearing at me. I want to be able to spot all those scalability and performance issues in a dev environment that has a reasonable amount of data. Now, we're about to run into these old problems again. First of all, the data is huge. Typically, most of our production databases won't fit on my dev workstation. If it's got more than a terabyte or so of data, it's unlikely that you're going to have a dev environment that's big enough to be able to host that. And second of all, we run into the data privacy issue. Now, like I said, that's kind of a separate and bigger problem, which definitely needs to be solved. And in a minute, I'm going to show you where that fits into this whole process. But we're not going to get too big on data masking at the moment, because that's kind of a whole session in its own right. But what I'm going to do now, because Sander is the person that wrote dbaclone. So rather than me giving you an overview of it, I'm going to let Sander do that himself. So Sander, do you want to just tell me, and I'll tap next, just say next slide and I'll tap for you when you want.
Sure. So dbaclone was developed because I had the same problems with large databases, and I need to get them to the developer laptops. And then SQL clone came along in the really, really early beta versions. And I looked at it and then I thought, I could probably make this in PowerShell. So it was a little challenge. And then I started to do stuff and look at how it actually worked. And it came to be a lot of more work than I first anticipated, but it is working. So if you go to the next slide, it kind of works with images. So the image is a virtual hard disk, a VHD file. And what it does in the process is it creates that VHD file. It mounts that to your workstation that you're currently working on. And then it restores the database into that virtual hard disk. And then it detaches the VHD from your workstation, and you basically have your image. From that image, you can create something called a clone. So if you go to the next slide, the clone is is the delta between the image and what happened in the database. So you could, it's a really small copy of the database. You need to go to the next slide, Alex. So, and these clones can, you can create multiple clones from a single image, and you can distribute that using file shares and get everything going. And that process really helps you, because if you have a multi-terabyte database, the database on your disk will initially be around 300 megabytes. So instead of 3 terabytes of data on every single dev machine, you will have like 300 megabytes. I need to warn you though, that clone will save all the changes you make to that VHD. So if you do a large index rebuild on your clone, and it's going to generate 1 terabyte of data in changes, then you will have 1 terabyte and 1 terabyte clone. So that's kind of how this works. You only save the delta on your local machine. And that really helps you get those large databases distributed to your dev machines. So I can actually show you how that looks like. So let me share my screen. So this is the same script we had before. It has the build, but now before we're going to do any builds, we're going to create a clone. And I'm going to call this data, Stack Overflow 2013 data. That's going to be my clone name. It's going to be based on this image. And if I go to here, I can say get DCN image. And this is my image from my that I created earlier. This one is 52 gigabytes in size. So your image is always going to be the same size as your database, but the clone is going to be significantly smaller. So if I run this script, there we are. It's done the build. Now it's going to do the clone. There's the clone. And now it already published the data, the database project to that database. So let's look at how large that actually is. So this is my image, which is 52 gigabytes in size. Let's go to the place where I actually saved it. Docker, clone. And my initial image is just 300 megabytes in size. It's the same database. It's still the 52 gigabytes of data, but only the initial clone is there. So the maximum size of your image can be 64 terabytes. So unless you're going over that, you can just use this to make your clones. And I really doubt if anyone is actually reaching that size at the moment. But yeah, that's how easy it is. So if I go in here to my Docker image, I can see my data. And yes, here are all my tables. So this is based on that image of 52 gigabytes in size. So that's how easy it is. Back to you, Alex. I can't hear you, Alex.
Yeah, you're on mute.
You're muted.
Yeah, I lost my Zoom control somewhere. That's what happens when you got 4 monitors. So just to summarize what Sander was able to do there, from a single script in a few seconds, he's able to spin up a Docker container, which is his SQL Server instance, create a clone of an up to 64 terabyte database, squirt it onto that container on your local machine, and that bit is tiny. It doesn't take up any space on disk, except it's a full editable, readable, writable version of the 64 terabyte database. And then he's able to deploy your latest version of source code against it. So how does this all fit together? So let me focus on, so we start off with your production database. And now I want you to imagine a physical line between the production side of your system and the dev side of your system, and the sensitive data goes on the production side of your system. And then we need to create that image. Now, this is that process that Sander spoke about, which is basically restoring a full restore of the production database into some sort of, it's a full restore of that. So it takes as long as a full restore of your database would take. So if you've got a 64 terabyte database, it's going to take a while. But this is a point where also I recommend you do some masking on it. So what I would actually do is I would do a full-on regular restore, and you should be testing your restores anyway. So you should already be restoring your production database backups somewhere behind the production firewall anyway. So when we do a restore, at this point, you carry out some sort of masking process on it to make sure you clean up all the sensitive data. And then we can create this dev database image, which is basically just copying that. This is the point where we actually create the image that Sander was talking about. So we've restored production, somewhere on the production side of the firewall. We've run our masking scripts to clean up the database. We can then create this dev base image, and we're going to put that somewhere that all the developers have got access to. From that point onwards, we don't need the masking database anymore, so that can die. We'll just kill that one, and we'll spin up a new one when we need it. And now developers can spin up their dev databases as and when they need them, and they should treat them completely disposable. They spin them up for a short period of time, they do that piece of work, they check in their code, they delete it. And every single time they do this, they're provisioning a new dev database. We need to get out of the mentality that you need to maintain a dev environment on your machine. You don't. You spin it up for as long as you're doing a piece of work, and when you finish that piece of work, you kill it and you spin up a new one. And that way you always know you're working off the most recent dev image. It means that your dev environment is going to be reasonably up to date with production. The next thing you do is you're going to deploy the latest version of your source code against it, which is effectively a full-on test of your next production deployment, because we've got the previous production version of the database with all the sensitive data masked out. We're deploying the latest version of our source code. That's exactly how you would be doing your production deployment. So every single time you're starting a new development task, you're practicing a production deployment. And I'll tell you what, it's far more likely that if you're going to have an issue with your production deployment, you're going to catch it in the dev domain rather than the production domain, which is great. It's going to give you a huge amount more reliability when it comes to production deployments. You can then do your work in an isolated environment where you don't need to worry about everybody else's. You can eventually check it into source control with some sort of sane branching pattern that avoids you getting too tied up with things. You can then create your packages. I apologize, I've just copied this slide from a class I was doing for Octopus Deploy. So you can then create your packages and deploy them using your release management tooling of choice, which is taking those NuGet packages and deploying them to your various different test and production environments. And there you have the whole cycle. And then on some other schedule, you're going to refresh that dev base image. Maybe that's a weekend job, maybe that's an overnight job, maybe that's a regular job that happens at the end of your sprint, so that every time you do a new sprint, you get a new dev base image and all the developers start using a new dev image. That's kind of how we see this whole process fitting together. But certainly that process to create the new dev image and do all the masking and stuff, that's some sort of automated regular task that runs overnight. But then the creation of dev environments is super straightforward. The other thing I'd say, and this is relevant to this new weird era where we're all working from home, you want your clones to be physically close to the base image, because you don't want a lot of a latency between the base image and the clone that your database is working off. So maybe in a world where we're all going into the office, sure, maybe these clones are on your local laptops, but in this COVID era where we're working from home, maybe these environments are being spun up on some server back at HQ, and you log into it to do your testing or whatever. I don't know. But ideally, you want the latency and the network to be strong between your clone and the base image. But that's kind of it. That's how it all fits together. So what have we learned? Shared databases are evil. Stop using them. Better provisioning leads to better and safer deployments. It leads to better throughput of development, and just generally a more efficient and more reliable development process. And the tech that you need to do this is available, and pretty much all the tools we've used today are free or have a free offering. GitHub is free for open source stuff, I think, and up to a certain level. It's only really once you start getting into enterprise stuff that you need to start paying for it, but there are other alternatives there. Git, the underlying source control system, is free, so GitHub is just where we chose to host it. What else have we got? We've got dbaclone, that's open source. Say thank you to Sander for that. We've got Docker itself. There is a paid version of that. I've not looked at the licensing of that for a while, but there's a free and a paid version of that. You should also be masking your data, is another thing that you should take away from this. We've not covered that in this class, but that's an entirely different class in its own right. Other tools are available. So we've used Git as a source control system, and really that is what you should be using. I'm not really going to advocate for any other source control system at this point, but you can host it in a variety of places. We've used GitHub, but there are other places you can host your Git repos, and they're all pretty good these days. I don't have a particularly strong reason why you would go for one or the other. We used SSDT for our database tooling, but there are all sorts of other great options. You've got Redgate, and I know Steve Jones is part of your community, and I'm sure he can talk to you all day long about why Redgate is better than SSDT. I'll let him do that. You've also got various open source migration runners, Flyaway, which has recently been acquired by Redgate as well, and dbup, which is not yet acquired by Redgate. You've got Liquibase, you've got various others. When it comes to cloning, we use dbaclone, but there are other competitors. There aren't any free ones as far as I'm aware, but Redgate SQL Clone is very good. It's packaged up as SQL Provision or their Redgate Deploy offering now, I believe. You've got Windocs, which is kind of a bit like Docker and SQL Clone combined. They were kind of the first to come along in the database provisioning space. It's all nicely wrapped up into a single solution. It costs about the same as SQL Clone, I think. One of the big challenges there is you're betting against Docker because you're using Windocs instead of Docker, and that feels like a pretty bold gamble to make at this point. That said, they do have some support. There's some features that Docker doesn't have. So, for example, Docker doesn't support Active Directory authentication yet, but at least I don't think they do yet. It was always on the roadmap. I don't think they've got there yet. Sander, if
you can make it happen.
Pardon?
You can make it happen.
You can make it happen. Okay. Doesn't sound like it's really supported yet.
More work.
Windocs has that working out the box. And if you want more options, and take a look at Actifo and Dalfix, but they are more expensive to the order of magnitude of roughly 10x what Redgate is going to cost you. So they've got various nice features, but for most people, they're kind of out of our price point. So I'm not really going to worry too much about those in this, other than to say they're there. I've drawn a lot on a bunch of my favorite books, and there are a whole bunch of good ones. I wrote a blog post if you want to read more about the same source material that I've used for this. I wrote a blog post a few months ago for the Octopus Deploy blog, called my DevOps reading list, and it did quite well. It gives you this nice decision tree that points you at a book that is probably going to be relevant to you if you want to learn more about the DevOps space. So I encourage you to go read that. Sander has used a few extensions in his demos. So Sander, would you like to speak a bit more about those?
Yeah, so I didn't actually demo the tsql tests running, but that is in one of the scripts that you can actually download as well. So if you run those, it runs just the tsql tests and shows you that they're all successful. You can use the DST-SQL test generator, which is, by the way, also on the PowerShell gallery. So you can just install that from using install module. You can also use the SSDT with T-SQL template. That is a state-based deployment style that you can use. I think in a lot of situations you can use state-based. In others, migration-based would be better. But in my case, we primarily use state-based deployments. So that's why I generate that template. So those are tools we used. They're also free. So why not use them when you can? By the way, I see that we have a question about the images. So Shane asked, he doesn't really understand why the dev image is so much smaller. That's because it's the differencing disk. If you look up virtual hard disks, you can create a differencing disk based on another VHD. And that's only the delta that is being saved. So it has a link to the original image, so it doesn't have to be as big as the original image. You can create as many as you want. You can actually create an image from a clone and then clone that image again. So that's how far you can go with that. So that's why it's so small, and I hope that answers your question.
Cool. Actually, I just forgot to mention one of the things I probably should have said about SQL clone. I mentioned that it basically did the same thing, that it cost money, but I didn't mention why you might want to do that instead of use dbaclone. Basically, SQL clone comes with a nice rich UI. It comes with better management features for managing who's allowed to spin up this clone and that clone. You get kind of better security stuff there. And it's got various data masking features built in, which is the whole stuff that we didn't talk about in this class, but is also important. So there are some really cool features about SQL clone, but yeah, it costs money. Whereas dbaclone basically gives you a free version of the cloning part of it, but is PowerShell only and doesn't have a nice UI and stuff.
DBA Tools has a masking function, masking command as well.
That's true.
Which, by the way, I wrote.
Masking stuff that comes from DBA Tools as well. The last thing I want to say is I'm on the organizing committee for a conference called Data Relay. In the before times, what we used to do is get all of our speakers onto a big bus, go through the UK, typically mostly England, and we'll put on one conference, basically 5 SQL Saturdays in 5 days is basically, if you want to imagine that, that's basically what we did. In retrospect, that's basically the definition of a super spreader event. Get a whole bunch of people all together in one city, make them all very tired, get them all onto a bus together, drive them for a few hours in that same confined space, then get them really tired again at the next place, get everybody's immune systems really low. So yeah, it's not something we're going to be doing anytime soon in person, but we've been thinking about how we can take it online. And we come up with the idea of we're going to go all old on folks and do an old English kingdom style thing. So we're going to have a Northumbria, Mercia, Wessex, Dumnonia and East Anglia edition of Data Relay. We're going to do 5 events in 5 evenings. We're just going to do it smaller at this level. Just it's kind of a minimal viable product at the moment. It's kind of a best of Data Relay. We've got some of our most popular speakers from those different regions of the UK. And we're going to do 1 event a night, 2 speakers per night. And we're going to run it in the week of April 19th to April 23rd in a few weeks' time. So if you want to attend that, head to datarelay.co.uk. It's going to be evening time, UK time, and lunchtime-ish US time. So check out the agenda. If there's some sessions there that you like the look of, then register. It's free. So come along. It's going to be a lot of fun. And that's all from us. So I think now is the time to take any questions.
I think there's a question from Kim Young to you. Can you talk a little bit about what the difference would be when you go from dev to QA to user acceptance to prod? It's probably a good question for you.
Okay. So From a provisioning perspective, which is mainly what we've been talking about in this class, in this session, I've been doing a lot of training recently. I keep saying the word class instead of session. I apologize. From a provisioning perspective, you need to make a call. Are you going to use a clone for this, or are you going to use a regular database for this? If you're going to use a regular database, I encourage you to still practice infrastructure as code and still try and source control your config files for installing SQL Server and source controlling the your virtual machines using whatever tooling you use to provision your environments. At some point, you're going to move from dedicated environments to consistent shared environments. That's inevitable. The closer you get to production, the more likely you are to use a shared environment because you want it to be as production-like as possible, and you're not going to be running your production workloads on a container, on a clone. So it's inevitable that you are eventually going to switch from clones to full SQL Server instances. What I would say is try to imagine your pipeline less as a pipeline and more as a heated towel rail. Try and do as much stuff as you can in a parallelized fashion as early in the pipeline as you can, and try and use basically clones for much of it as you can, and figure out what do you really have to do on a shared instance, because the less stuff you can do on that shared staging instance, the easier it's going to be to manage those resources, and the less issues you're going to have with competing resources and trying to run multiple things at the same time and so on. So the more stuff that you can do on a disposable throwaway environment, the better. And also the easier it's going to be for you to parallelize it, because the whole issue of it means you can get through all of your testing an awful lot more quickly, like radically more quickly, so that you can go from code commit to running in production in hopefully multiple times a day would be the goal. The next question is about deploying code from source control. That's kind of what Sander did in his first demo. He was using SSDT as his database deployment solution, where he would create those NuGet packets, those DAT packs from based on the source code, and then he would run a script using DBA tools or SQL package or something else to deploy those packages, which are basically fancy zip files, to generate the scripts and deploy them. He used SSDT for that, but as I said, other tools are available. Redgate's got a bunch of good stuff. There are a whole bunch of open source migration runners, and you would probably orchestrate all that using some sort of release management tool, whether it's Azure DevOps, whether it's Octopus Deploy, whether it's Jenkins, TeamCity, something like that.
There's, by the way, there is a PowerShell module called dbops, which uses dbops. So dbops, and that actually uses that dbop library.
I didn't know about that. That's very cool, and that might be useful for something that I'm working on at the moment. DBOps.
Yeah. And it's a module on top of dbops, and I played around with it some. It's got some decent functionality.
That's cool. I mean, I hate the whole pattern of just stick ops on the end of everything to make it cool. I hate that, but I like that the module exists.
I was pushed in that direction as I was exploring Flyway, and realized that Flyway didn't work, at least the freeware version, didn't work for versions of SQL Server before 2014.
Yeah, that's one of the ways they've decided to
get you to buy the
I actually think that's quite a nice pricing model, because it means that all the new startup-y people get it for free and all the open sourcey people get it for free, but all of the people who are rich enough to maintain old versions of SQL Server and presumably have been well established, they're the people that they make their money off, which seems to make sense to me.
I'm still typically a SQL change automation guy, but I love working with the other tools too.
I love SQL change automation. I hate that they renamed it from ReadyRoll, but that's just me having sour grapes because I liked how my old UI worked and so on.
Of course, understood.
Cool. Do we have any more questions about the session or should we hand back to Mark?
Any other questions? And a reminder, you're likely on mute.
Sandra, will you send me your syntax highlighting color scheme in an email, please?
Oh, do you like my theme?
Yeah, that's good. That's some nice colorization.
Yeah, I've been playing around with it a lot, and I can also send you my theme for WSL, like the new version of the terminal, Windows terminal.
Sweet,
So,
sweet.
So I had some follow-up questions if you have time. So we're doing this exact same process in our company, moving to containerization and programming locally against containers. Our databases are ginormous, though. We have some tables that are terabytes alone. So I like a lot of the stuff that you guys have taught today, but I'm just trying to figure out how I can better apply that to the size of databases that we have.
How are you more than 64 terabytes?
In a single database? Is that
right? In a are any of your individual databases greater than 64 terabytes?
I'd have to go look. Probably not the individual ones, but for the whole server, right?
No, it's per database, I believe. So the perfect user for all of these tools is somebody whose databases are 63.5 terabytes and aren't going to grow.
So, I mean, I asked the question about really the differencing disks there, but so are you loading all of that data on the person's local container, or how? I'm just not really understanding that.
So how that works is you have your parent. Let's do let me explain it in a different context. So you have a parent and a child. So the parent is the image, and the child, the differencing disk that you have locally has a direct connection to that parent VHD. So all the objects are in that parent. So you always have to, you need to have a connection to that image. Otherwise it's not going to work. So it's referencing all the objects from that image to that differencing disk. That's why it's so small. And that's why you only have like 300 megabytes, because that's the initial size of a VHD in that configuration. And then any change you make on that, if you clone that and you work in that database, any change that you make is going to be locally. So it's only going to be represented on the differencing disk. So if you change a table and add a column or anything like that, that's not going to be in the image, because that's read-only. That's not going to be touched. So the cloning part is it's just 300 megabytes. So if you have like a 60 terabyte database, yeah, you can provision that to your developer machines, and then you can do that multiple times. By the way, you don't need, doesn't have to be just one. And like Alex said, sorry, go ahead.
I think I was about to say the same thing that you were about to say. Just make sure you stick it on a fast network and make it physically close to the image. I think that's probably what you're about to say.
Yeah.
Okay.
And you talked about the objects there. Is the same true of the data?
Sorry, say it again.
You were talking about the objects there. Is the same true of the data, that all the data lives on the parent?
Yeah.
And if you make a change to the data, that will be local.
Yeah. So if you, that's why I mentioned that if you do like a large index rebuild and it generates 1 terabyte of data, that will be represented locally. So you will have, your disk will be full in a matter of minutes.
It would be really cool if there was some some sort of features in dbaclone that protected you from that. Some sort of something that tracked that, by the way, this is growing really, really big, and in a minute I'm going to kind of kill it because otherwise you're going to be in trouble.
It's going to be really hard to do that. Yeah, I can look at that.
I'm not saying it's easy. I'm saying that those sorts of features would be really nice.
From the point of view of the local developer, they're not going to notice whether something is on the child or parent. It's just all going to be seamless for them, right?
Yeah,
it's going to be the same.
Right. Okay, thank you.
It's the sort of thing that feels like this should have a huge performance impact, but surprisingly not. It is staggering how well this works. So one thing to be aware of is all your query plans will be exactly the same as if it was a regular full fat version of the database, because as far as SQL Server is concerned, it doesn't know about this. So as far as SQL Server is concerned, it's just running normally. So if you're into checking the query plans, that will all be exactly the same. But just the raw performance, it feels like magic when you start doing it with your stuff. It's like, surely this shouldn't work. It just feels like it's local. It like the performance hit that you get from this is virtually negligible for most people.
Yeah, I mean, this was a lot of our same problems. We were worried about how people would do performance testing and improvement. So this is an awesome thing that hopefully will help us a lot.
Yeah, that's exactly why you want to do these kind of things, because if you write a query and you can't test that against your production load, then it doesn't work, because if you have a small database like 100, smallest for me is like 100 gigabytes. But if you go to 1 terabyte of data and then your tables are half that, then you're going to run into problems if you don't write proper queries. So. It's even funny if you open the, I can actually show that. I'm going to show it anyway. So this is the folder with the clone. So this is my Stack Overflow database, which is the clone. And these files are initially all 13 gigabytes in size. But the clone is still only 300 megabytes. Because this represents that image. So what those files which are in the image. This is just locally. This is the VHD, which is 300 megabytes. And this is the maximum size, data, and the log. So it may be confusing at first, but it just works.
Oh, it totally is. It is totally confusing. The first time you do this, it's like, this is counter to everything that feels like it should work.
Right. And that's why I was asking, because it did feel like, how is this working?
It's magic.
It is complete magic.
Well, awesome. I'm excited to try it out.
Yeah. If you have any questions, let me know. I'm happy to help.
And do you accept pull requests?
Oh, yeah. If you have, if you want to help out with this module, feel free. It's open source, so I have too many projects, man.
And then is this recording going to be available to us that we can rewatch again?
Yes.
Yeah. So we'll post it to the group's YouTube channel.
Okay.
Likely later today.
And are you doing any sort of coordination of feedback or not? If you've got any, if anybody has any feedback, that would be the greatest thank you that you could give us is some constructive feedback.
It was fantastic.
It was excellent. Yeah, I liked the addition of the story stuff as well. Like, it had this nice mix, right? It made it a little bit more human. So there was some storytelling. There was some educational stuff. The nice mix of the demos too. And it was nice seeing you two work together. It was a good presentation.
Cool. Well, our Twitter handles and I think our emails are in the slide deck. And I don't know, Mark, if you'll be if you have any sort of regular feedback thing, or if anybody wants to send us something, just send it our way, and we appreciate that.
Of course. Well, I guess it's about time. I greatly appreciate it. Alex, Sander, fantastic. As Peter mentioned, flowed well. It was a great level, talking about things that we all should know about, right? So fantastic. Good job. So
Thanks for having us.
yeah, thank you. Well, with that, I guess we'll call it a meeting. And as Alex mentioned, if anybody has any feedback, if you want to send that to us or send it directly to them, feel free. Definitely check out their links. There's links in the abstract. And so if you didn't catch those on the chat, you can go out to the event site and pull out some links. There's 4 GitHub links that they've provided in their abstract. So some additional information. Well, again, thank you. Appreciate it very much, Alex and Sander. Have a great evening.
That's great.
You as well. Bye-bye.
Thanks, everyone.
See y'all. Bye-bye.